CIT 1124, Module 12, Wireless LAN Concepts. Let's take a look at everything that is in this section here. We're going to start with components of wireless LAN. We're going to talk about a lot of different types of wireless LAN technologies. Some of them, as a network administrator, you will use. Some of them you'll just be a client for and you probably won't use. Then we're going to get into the components of the wireless LAN. We'll talk about how the wireless LAN works. And then talk in scalability terms of how CapWAP works, and that is more of a scaled wireless controller technology and how you can manage a whole bunch of antennas from one device. Get into channel management. We'll talk about channels. I don't know how that got at the end. It probably should have been up near the beginning in introduction, but it ends up near the end. We'll get into threats, and then we'll talk about some of the security methods that you can use, and that'll get us through Module 11, or 12, excuse me. So introduction to wireless, starting off with first two slides, just different types of wireless technologies. Wireless PANs. Bluetooth is probably the most commonly utilized solution, and that comes under IEEE specifications 802.15. As everyone knows, the IEEE specifications are what organizations will manufacture to standards so that you have interoperability between different devices. So if I have a Samsung phone, I can connect to a D-Link access point, or if I have a Bluetooth speaker, I can connect to it with any kind of device that will run Bluetooth. The other one would be Zigbee, would be another wireless PAN example. Zigbee was this bizarre, I guess it's still being used. I haven't come across it in a very long time. It was this home automation. We're going to put in a very low frequency wireless antenna in every single device in your home, and you'll be able to manage the whole thing. So home automation kind of started with Zigbee. It may still be there. It may still be around. I haven't run across it in quite a while. The other standards below that, wireless LAN, I think we're pretty familiar with those. In most cases, you're going to be a network administrator. You're going to run across some wireless LAN stuff, and you should know the different types of wireless LANs. You should know the wireless frequencies you can utilize. You should know how many channels you have. You should know the different security protocols. A lot of stuff on wireless LANs. If there's something to concentrate on, I would definitely look into that section. Then the next two get into wireless MANs and then wireless WANs. And wireless MANs, a large geographic area like a city that's going to have some kind of specific wireless technology. I guess an example for a wireless MAN would be 5G cellular right now, as that is a technology that's moving forward, and you can get it in some places, but you can't get it in others. So I think Chicago, you're okay. But if you're out in Glen Ellen, I don't think it's available yet. So it'd be more of if you had a device like an iPhone or a Galaxy that would connect to 5G, it may not be available everywhere. So it's just in a metropolitan area. And wireless WANs, more specifically, things like satellites and things of that nature. So take a look at that. This slide just gets into just Bluetooth technology in general and what is Bluetooth. It is a wireless PAN standard, so personal area network. I remember when Bluetooth first came around, we were first using it, and it was awful. It would interfere with all of your wireless networks. And because it uses something called frequency hopping, and the same frequency that your wireless, your 802.11 B and G networks would use, and frequency hopping would hop all over your signal, and it would stop your wireless network from working whenever you ran Bluetooth. So that was a big problem. Oh, golly, probably 16, 17 years ago. And it's gotten a lot better now. So it uses what's called adaptive frequency hopping. So it'll only hop in space that looks like it's not utilized, which has really solved that problem. At no point do I hear anybody saying, gosh, I turned my Bluetooth wireless on, and now my Wi-Fi doesn't work anymore. It's not a thing anymore. They do get into a couple of different specifications about Bluetooth. Bluetooth was invented by, I believe, Ericsson, and Bluetooth was a Nordic god of wireless. I don't know. So he was somebody. Anyway, the whole concept of Bluetooth was to have a low energy solution, and Bluetooth really did um, does work well in short ranges, and it's found its niche between handheld devices and other things that you'd like to connect to. There was a time when there was kind of a thought that, oh well, we can pass IP traffic across a Bluetooth frame header. We should just use Bluetooth as our internet service, as the frame header for our internet for devices in our homes, especially in like small spaces where apartments next to other apartments. You'll have a lot less overlap of devices and people utilizing that same open license space. If we use Bluetooth, the signal won't travel as far. That kind of went to the wayside, and what we're left with is the Bluetooth that we're using now, and I think everyone's pretty familiar with it. It does use a pairing solution. Its distance limitations are much smaller than our 802.11 counterparts, and it does some really cool things like it saves energy like no other wireless technology. So it's got, I believe, 5 different energy saving settings that it can go into. And you may have noticed if you've got a Bluetooth headset, you don't have to charge it that much. And that's because it does not use a lot of energy to make that wireless signal. Second bullet point on this slide is the WiMAX solution or 4G technology. Just the ability to pass high-speed internet across to devices that are subscribers. There are 2 parts to the WiMAX solution, or the IEEE 802.16 wireless LAN standards. When you hear about 4G, WiMAX was one of the first solutions that was available that would give you a blanket of wireless antenna to the masses for the ability to stream audio and video across a solution. So WiMAX is really your 4G type of solution. Other types of solutions that are out there, cellular broadband, which we're pretty familiar with. So when people talk about cellular broadband, there are wireless carriers. I used to use something called Fox Valley Internet years ago, and they would provide internet to locations that didn't have a hardwired solution in that particular location. So you can use them for secondary markets. There's a lot of different providers out there that have access to all kinds of very tall things. So they can get line of sight, and you can line your antennas up, and you can have possibly a secondary solution for internet to pass from one device over to another. And then satellite, of course, you can run internet across the satellite solution as well. The next standard we get into is the IEEE 802.11 standards. These are all your wireless LAN standards. This is something you'll probably be most familiar with if you become a network administrator in any business that you find yourself being in charge of their network. You're probably going to have wireless LAN. You'll probably have more than one wireless LAN network. It's not a bad idea to memorize really the bottom of this chart and then kind of go up, because that's where the most useful stuff is. So 802.11ax is a very, very high speed wireless LAN solution. I don't see a lot of it right now, but it will be coming. 802.11ac, something that a lot of users are using those already. They're using A and AC. Very fast rates, up to 450 megabits per second to 1.3 gigabits. Very, very fast. 802.11 was the first kind of breakthrough, really fast technology that went up to 600 megabits per second. And 802.11n uses a solution called MIMO technology, which just means you can use more than one antenna at a time for your devices to communicate. And then the ones above that, your G's, your B's, your A's, and then your just plain old standard, really kind of slow at this point. You don't see as much of that as you used to. G was kind of the breakthrough several years ago, where you could go 54 megabits per second. That was fast enough to stream almost anything that you were looking for. When N came around, everything got real quick. It was equivalent to most of your wired networks at that point, and then things have gotten faster and faster. So, your wired networks used to be at 100 megabits per second, And then you could say, oh, we have 802.11g. It's a little bit behind there, 54 megabits per second. Okay. And then N came out, and it's faster than 100 megabits per second, but data-wise, from a wired perspective, you could have a gigabit Ethernet, which would go at 1,000 megabits per second. And you can take all these numbers with a grain of salt, because you're not really going to get those speeds. You're going to get about half of whatever they say in actual throughput of your information, and that's true of your wired as well. Very rarely do you get gigabit Ethernet solutions that actually send and receive at gigabit speed. If you get 600 megabits per second out of a gigabit Ethernet, that's pretty good. That's a pretty fast solution. So just keep that in mind. This is a chart that you should be aware of. The next thing gets into just an overall, hey, there's all these radio waves that we can utilize and put information on them. How does that work? And they do a nice job of kind of showing you the different devices there of what's posted where. And I think the neat thing to look at here is you kind of go from left to right, and you're like, okay, well, what is it that we're doing? Well, we've got invisible rays on the left, and we have invisible rays on the right. And then in the middle, we have that just spectrum of visible light that you can identify and you can see, and you'll use that to identify different colors. To the left of that is really where we're going to spend our time, where you see a television antenna or a radio antenna and a monitor and a microwave and a satellite, and then I guess that's a remote control for infrared communication to a television. In all cases, what we have are radio waves that we're going to put a modulation on. When I say a modulation, it just means that we're just going to put data into that radio wave. Now, I don't want to get too deep into the whole technology on how that works, but it's pretty straightforward. There is a frequency that you can tune into. So the frequency is how often the wave will come through, and then you can measure off of that frequency essentially the height of that particular wave, and you can attach a value to that height of that wave. So in any given sine wave, you're going to have some waves that are going to come in at the specific frequency, and if they come in lower, those are going to be translated into zeros, and if they're higher, they're going to be translated into ones. So that's essentially what's going on with those. Now, there's all kinds of different frequencies that are out there that you could utilize, and some of them are what are called licensed, and some are unlicensed. So, for instance, in an unlicensed bandwidth solution, you're going to have to use a frequency that is 2.4 gigahertz or 5 gigahertz, or there's actually another one at 900 megahertz. It didn't make the list on this page, but these are the unlicensed bandwidths that you can use so without any kind of license, through the FCC, who manages the invisible waves that you can send data across. They say, okay, if you wanted to buy something and you are an unlicensed radio engineer, which is what basically we are, you'll be able to utilize it in the 2.4 or the 5 gigahertz ranges, and that's the space that you're allowed to use. Your neighbors, anything else, anything that comes with wireless technology is going to be in one of those ranges, and there will be interference between those different devices. So if you've got a radio-controlled toy, or you've got radio-controlled lights, or you have radio-controlled anything, it's going to be in 2.4, 5, or as I said, 900 megahertz. So just keep that in mind. Keep that in mind. This slide just gets into the different types of standards and who creates them. The IEEE is the main one that we've talked about, but there's also the International Telecommunications Union, and more recently developed the Wi-Fi Alliance, because there was different 802.11 standards, and A and B, the standards of A and B were not compatible, and A and G were not compatible. So people would be buying equipment and not knowing which one was which. So the Wi-Fi Alliance kind of stepped in and said, well, we're going to put a stamp on stuff, and we're going to identify it as being compatible, so you can check these stickers, and just a regular person would be able to successfully purchase some Wi-Fi equipment, and it will work.